Hello everybody, welcome to Software Fundamentals Part 4, where today we're going to learn how to create a simple LC and MS method using SCIEX software. So as you can see, we're on the home page of SCIEX. And first of all, we're going to create an LC method. So to do this, we want to click here, LC method, new LC method. And then this is typically what comes up when we create a new LC method. So the first thing I like to do is to save. So we press save as. So we call this software fundamentals underscore LC method 2. Save. And the first thing I want to do is alter my injection volume, as you can see here. So it's set to 10 microliters. So I'm going to change that for 1 to the method that I'm creating today. I'm going to change my stop time to 5, which is when your method will end. And then I'm going to set the initial parameters of our method here today. So first of all, flow. So I'm going to set this to 0.5 for my method. Then we've got concentration of mobile phase A and mobile phase B. So typically A is aqueous, B is organic. So initially I want B to be 20, and then A will automatically update. And then underneath here, we've got our pressure limits of our column. So you just want to make sure the maximum is to what yours is set to, or because if it exceeds the maximum, your method and run will stop. Okay, so we're going to make a simple gradient method together today. So as you can see, we've got our initial parameters here already set up. So if we set up a method, so we have this as 0.5, keep this the same. We set this to 3 minutes. And then we change the concentration of B to 90, you'll see that A automatically updates. Then if we change this to 3.5 and we keep that the same, and then for a typical gradient, we would then reduce the organic, which is B in this case, in the method that I'm making. And then if we do this again and keep this where it is, so this is our gradient at the moment. And as you can see, as I was altering this gradient, you do see that we have this image on the left will change. And as you can see here as well, if your stop time is exceeded, so this has now gone to 6 minutes, it will error here. So it'll tell you that there's an invalid range. So yeah, you want to be careful of that. So then if we just look at our auto sampler settings, so we've got our sampling speed, which is default to 5, but obviously you can alter this. And there's many different things you can do here. So you can alter your auto purge settings, rinse settings, injection settings, sample rack settings. But today I'm not going to go into too much detail through this because this is just how to make a simple LC method. So the thing that you typically look at is your cooler temperature. So for what we're doing today, again, I'm going to keep this at 15 because that's okay. And we can also alter our rinse settings here too. I'm going to leave that alone today. Then we've got our column oven. So today for what I'm doing, I want my column oven to be 35 and I want my maximum temperature limit to be 50. Then there is an advanced setting here. So wait for temperature equilibration before the run. So I've got this tick because that's what I want to happen. So yeah, that's it. That's how we create a simple LC method using SCIEX. So I just want to make sure this is saved again. So if I press save. So now we want to create our MS method together. So we go to home. Again, everything is quite self-explanatory and easy to use on the SCIEX homepage. So we then click MS method. New. So today I'm just going to create an MRM method, just a simple MRM method. So I'll show you how we fill this out. So my LC stop method was 5 minutes, so I want my MS method to also be 5 minutes. Iron source gas 1. So obviously you will have these parameters yourself, but I'm going to set these to 50 and 50 again. Curtain gas, which you will have acquired from your compound optimization, and your source temperature 2, which will be, in this case, 600. And then CAD gas, I'm going to change to 9. So you'll have got your parameters from your compound optimization that we looked at previously. Experiment type MRM, polarity positive. Again, you will have got your iron spray voltage from your compound optimization too. So today I'm going to set this to 1250. I want to settle in time of 5 and a pause time of 5. Okay. So let's fill this in together now. So we've got all of these parameters from our compound optimization. Our experiment is MRM and our polarity is positive. So today I'm going to just fill it in for a metron. So I want to change this to a metron, which is our group ID. Compound 1. So for the first transition, this is how I tend to label it. So I'd say a metron 1. Our Q1 mass of a metron, which is 228.10. I know what my Q3 mass is, so I'm going to put this as 186 for the first transition. And then EP10 CE, which you will have got from your compound optimization, which was 27, and CXP, which again you'll have got from compound optimization, which is 22. Okay. So let's fill in a second transition. So for the second transition, as you can see, it autofills to a metron 2. Our Q1 mass is obviously the same, our precursor mass, and then our Q3 mass for the second transition will be 67.90. And our CE and CXP from our compound optimization was slightly different. So we had this at 55 and 12. So now we filled in this table, and obviously if you have more transitions in the method you're creating, which you typically would, you'd want to alter the dwell time, which would then alter the total scan time. And obviously the total scan time affects the number of data points you acquire during the run. So as you can see, if we alter this, say, to 25, you can see that our total scan time reduces as you increase this and decrease it. So now we can add a second experiment if, say, for instance, you have some compounds you want to run in the positive and some compounds you want to run in the negative. We can actually create this in one method. So we can add another MRM experiment, which will go underneath here and use the exact same source and gas parameters. And we can change this to negative. And again, we can fill this table in the exact same as we did up here with our compounds we want to run in the negative. And then we want to save this. So save as, software, fundamentals, underscore MS method. And now we've saved our MS method. So that's how we create a simple LC and MS method using SCIEX software. So thank you for listening today, and we'll follow this up in some more detail later.